Okay, so in this particular video, we'll analyze the difference between distance versus displacement in a two-dimensional analysis. Okay. All right, so you notice here this particular video is a little different. Here you have a grid. Your first example here is you have a grid. Each of the block is 1 meters. So here's Pac-Man. Pac-Man is going to go from that particular location shown in the grid, and Pac-Man is going to go upward. And then from there, Pac-Man's going to make a right turn and go rightward. Okay, so this particular problem is pretty straightforward. It's going to ask you for distance here. So if you count correctly, the first movement was 3 meters, and then the second movement was 7 meters. So if you count, the green arrow there indicates a length of 3 meters, and then from the first stop to the final destination, that is a length of 7 blocks, which in this case would just represent 7 meters because in the schematic it shows that each block is 1 meter. Okay, so for total distance, you would simply add up each step taken, or the amount of ground cover in this particular case, regardless of direction. So 3 plus 7 would simply be 10 meters in this particular answer. All right, so the second one's a little more tricky. It asks for the total displacement covered by Pac-Man. So to find displacement, it's essential to understand that it is just the straight line between start to finish. Okay, it is independent of the path taken. So you want to go ahead and just draw an arrow that connects your starting point to your ending position on the grid. So in this case, to find the length of the blue arrow there, you notice here we have to kick in Pythagorean theorem because you have a right triangle. So to find the length, let's go ahead and apply Pythagorean theorem. Here I have c squared equals a squared plus b squared. C squared being our hypotenuse, which in this case represents the magnitude of our displacement. All right, so if we just plug in values, one, the leg is 3, we'll square that. The other leg is 7 meters, we'll plug in 7, we'll square that. And if we sum it up correctly, you should get that c squared is equal to 58. And then from there, we can just take the square root of both sides to solve for c. So square root of both sides would give us c is equal to radical 58, which is equivalent to about 7.616 meters in decimal place. Now, I do want to point out that you cannot just stop here. Displacement is a vector. What we just calculated is just the magnitude, the length of that blue hypotenuse. So you're not done. You would only be done if a question asks you for the magnitude, right? So if it asks you for magnitude, you're safe there. There's less work. You're just done completely. There's no need to find any extra thing. But this particular phrasing here says total displacement, and it does not use the word magnitude. So therefore, we have to keep in mind that displacement is a vector. It has to have a magnitude and a direction. So for these two-dimensional analysis, the direction cannot be plus or negative. In this particular diagram, you notice the blue arrow is pointing northeast. But northeast would still not be sufficient. We have to find what the angle is. Okay, because northeast is kind of vague. So in order to help you find the angle, I highly recommend that you draw a little origin, a little grid at the very beginning of the problem where the Pac-Man starts. And then from there, you need to find the angle touching the horizontal axis. So in this case, if you look at the diagram here, watch my cursor, that's the vertical axis that I'm tracing back and forth or up and down. And then left and right, that is your horizontal axis. You need to give your reference point relative to the horizontal axis unless otherwise stated. So it's just easy to be on the same page. Okay. There's theta, and so to find that particular angle, we just need to find a couple of things. We know that this blue dashed line is the same as it is over here. So in the green, the length from start to the first stop is 3. So therefore that length parallels it, so it's also 3. And then this bottom horizontal blue dashed line, that's also going to be 7. So you notice here in this first example, it kind of traces out a rectangle. Okay, so we have 3 meters there, we have 7 meters there. And then to find theta, I personally think it's just straightforward to just use tan because the diagram has 3 and 7. However, you already found the hypotenuse, which is 7.616 meters here. So at this point, you can use cosine, sine, or tangent to find that angle. I prefer tan for this particular problem. So I'll go ahead and do tan. Tangent of theta is equal to opposite over adjacent. So from this particular reference point in the diagram, my opposite away from that theta is 3, and then the leg that runs adjacent to it would be 7. So it's essential that you plug these values in the right spot. Okay. All right. So tan of theta would be 3 over 7, and then to solve for theta, you would do inverse tan of that particular fraction. So you notice my work here, I use parentheses to do inverse tan of 3 over 7. And if you are in degrees mode in your calculator, you should get about 23.2 degrees. So the proper way to express your displacement for this particular problem would be as such. You would say 7.616 meters and then comma 23.2 degrees northeast. Again, it's not enough to just say northeast. You must provide the angle. It's very specific then, okay? Or you can say 7.616 meters, 23.2 degrees above the positive x-axis. Your origin is going to start from where the problem starts, and then from there, as you can see, watch my cursor, that blue line, if I go upward, that would be the positive x-axis, and then I must go up. So that would imply that it's above the positive x-axis. So it's important to make sure you include the plus sign and not just say x-axis. Saying x-axis is very vague, so you have to be very specific. You have to say above positive x-axis. Okay. All right, let's do another one. So here you have an airplane. Again, it starts from the right side of the block here, just 2 blocks in. So if you keep up, it's gonna go ahead and fly west, and then let's just say it's gonna fly south next. It's circling around waiting for a spot at the airport, and then from there it's gonna fly east just to kill some time and fly south, and there's its final destination. So let's get total distance out of the way. Okay, so if you ask to solve for total distance, all you have to do is count each block, and I do want to point out for this one, each of the block here is 1 kilometer, so it's a good rule of thumb to always kind of scope out the information before you proceed with any given types of problem, and don't make false assumptions. So in this one, each block is 1 kilometer. So in the first leg, it's 1, 2, 3, 4, 5, 6, and 7. That'll be 7 kilometers to the left there, or west. And then next, you have 3 blocks, which is 3 kilometers south. But it's asking for distance, so we don't really need to know the direction. So I'm just going to count. That would be 5 kilometers. And then making that last turn would be an additional 5 kilometers, because it's 5 blocks. So if you add all the stuff up, 7 plus 3, which is 10, and then 5 plus 5 is 10. 10 and 10 makes 20 kilometers. And that would be it. No directions needed, because distance is a scalar value. Okay. Let's do displacement. Again, these types of problem, it's the displacement that's more challenging, that requires you to do more work. So to find total displacement, it is a direct path from your starting location to your ending location. So I want to draw an arrow from start to finish, and if you draw your arrow properly, it should be roughly like that. Okay. So to find displacement, it's not that bad. Okay. So first, you have to make a right triangle. In this case, the blue dash line that just came up should be a length of 8. So if you count 3 boxes, if you count the boxes going down, that should give you 8. Or if you look at the diagram, that's 3 down plus an additional 5 down would make 8. So however you want to think about it. And then the blue component would be 2. Okay. So at this junction, that would be 2 kilometers. And then to find the magnitude of the hypotenuse here, that's pointing south west, you would just do Pythagorean theorem again. So plug and chug. I don't really care which leg you call 2 and 8, but there's 2 square and there's 8 square, and if we do c squared is equal to 68, and then to find c, radical of both sides, so the square root of 68 would give you 8.25 kilometers. Now, again, that is just a magnitude, okay? So pay attention to questions and how things are being asked of you to on homework or on assessment. And then, so now we need to find the direction. To find the direction, go back to your starting point, put a little x and y coordinate. You notice these 2 black lines that are coming up, okay? That allows you to draw and reference your angle correctly. So you notice here I have that little coordinate from the starting point, and then all I have to do is find the angle that touches the x-axis. So you notice here my theta is going to be touching the negative x-axis, and it's actually going to be beneath it. Okay, so there's theta. Now to find theta, again, we can just use tangent. So really this is just a rectangle. Watch my cursor. From here, from the starting point, going left, that'd be 2, and coming down all the way to the finish line, that'd be 8. So the information here is actually in blue. So if you can just look at the diagram and just utilize that information, you can make it into a rectangle. It'd be 2 to the left and 8 down, which is same as this angle. But I'll stick up here just to make things a little easier for you. Okay. All right. So therefore, tangent again is opposite over adjacent. If this is your perspective in the third quadrant here, relative to this grid, looking opposite from that would be the leg of 8, and then this right here where my cursor is tracing on, that would be your adjacent, so that'd be 2. So make sure you plug in values correctly. So my opposite for this particular problem would be 8, and then my adjacent would simply be 2. And then to find theta, we do inverse again of 8 over 2, which is just 4. And your calculator should give you approximately 75.96 degrees. And the proper way to express your answer would be the magnitude is 8.25 kilometers and the degree is 75.96 degrees southwest. Okay, again, you cannot just say southwest. Just saying southwest is very vague because you have so many different angles that express the southwest. The second option to express this stuff would be the same magnitude, 8.25 kilometers, 75.96 degrees below the negative x-axis. And to me, it's not that bad. If you draw the grid, the angle lies beneath the negative x-axis. So therefore, it's not that bad to say it like that. All right, I hope that helps. All right, stay nerdy, don't be whack.